This video is for section 5-9. This has word problems that use rational equations where there's a variable in the denominator of a fraction. Here's an example. The township's voting tabulator can process the data in 28 hours. To speed up the process, the township rents a faster device. When both machines are used, the tabulation is finished in 12 hours. How long would the job have required if only the rented machine had been used? This is a work problem. We had some of these in an earlier section. There's a formula that you use for these kind of problems. Work equals rate times time. There are two machines mentioned in the problem. One is the township's current tabulator. The other is a rented machine. The problem gives us some information about those. So we have our current machine and we have the rented machine. The current machine takes 28 hours to complete the job. So its rate of speed is that it can complete 1/28 of the job per hour. Now let's consider the rented machine. We don't know the rate of the rented machine. In fact, that's what we're asked. How long does it take if you only use that machine? So let's use the variable t to represent the number of hours that that machine takes. Its rate is 1/t per hour. One of the sentences in the problem talks about if both machines were operating, that the tabulation process would take 12 hours. From that sentence, we can create an open sentence. What is an expression for the amount of work done by the currently owned machine? To find that, you take its rate and multiply by the time that it's working. We're told that it works for 12 hours. To that, we'll add the amount of work done by the rented machine. Take its rate and multiply by the time that it's working, 12 hours. When you add these together, that's the total amount of work, which is one tabulation job. Now we want to solve this equation. Let's simplify it up a little bit. 12/28 reduces to 3/7. 1/t times 12 is better written as 12/t, and that is equal to 1. Do you recognize this as an equation that has a variable in the denominator? The LCD is 7t, so let's multiply all terms by 7t. When you multiply the first fraction by 7t, the 7's cancel, leaving 3t. When you multiply this by 7t, the t's cancel, leaving 12 times 7, which is 84. And when you multiply 1 times 7t, you get 7t. Next, we can subtract 3t from both sides, getting 84 equals 4t, and then divide by 4 to solve for t. 84 divided by 4 is 21. Let's check that answer in the context of the problem. What was t representing? It was representing the time that it takes the rented machine to complete the job. So our answer is 21 hours. This equation did have a variable in the denominator, but the restricted value is a 0, which does not come into conflict with our answer of 21 hours. Let's try one more example. An airplane makes a 990-mile flight with a tailwind, and it returns flying against that wind. The total flying time is 3 hours and 20 minutes. The airplane's speed in still air is 600 miles per hour. What is the wind's speed? We're asked for the speed of the wind, so it makes sense to choose a variable to represent that. How about the letter W? Next, let's try to represent the facts from the problem using the variable W in some way. The first sentence talks about the airplane flying with the tailwind and against the tailwind. When an airplane has a tailwind, it can fly faster. When it's flying against the wind, it has a slower speed. Let's represent the speed of the airplane in both cases. With the wind, and against the wind. When flying with the wind, the airplane's speed is 600 miles per hour plus the speed of the wind. When flying against the wind, the airplane's speed would be 600 miles per hour minus the speed of the wind. Another fact given to us in the problem is that the flight is 990 miles. That is a distance. When situations involve distances and speeds, often the formula distance equals rate times time becomes useful. This formula can be solved for t by dividing by r. So d divided by r is equal to the time. The problem gives us the total time of the flight. Does it make sense that that total time is the time to fly with the wind plus the time to fly against the wind? That gives us the basic setup of the problem. Time with the wind plus the time against the wind will equal the total flight time. Let's fill in our algebra expressions. The time with the wind can be found by taking the distance, 990 miles, and dividing by the rate of speed, 600 plus w. The time against the wind can be found by taking the distance, 990 miles, and dividing by the speed against the wind, 600 minus w. And that equals the total time, which is 3 hours and 20 minutes. 3 hours and 20 minutes is equivalent to 3 1/3 hours, because the 20 minutes is a third of an hour. Because the left side of the equation has fractions, it might be helpful to change the mixed number 3 1/3 into the fraction 10/3. We have a rational equation that has variables in the denominator. The technique is to multiply all terms by the LCD. The LCD will have a 3 in it, a 600 plus w, and a 600 minus w. When you multiply the first term by that LCD, the 600 plus w's will cancel. So you really have 990 times 3 times 600 minus w. When you multiply this term by the LCD, the 600 minus w cancels. So you really have 990 times 3 times 600 plus w. And when multiplying this term by the LCD, the 3's cancel. So you'll have 10 times the 600 plus w times the 600 minus w. Because of the large numbers being multiplied together, a calculator would be helpful. 990 times 3 times 600 is 1,782,000. 990 times 3 times negative w is negative 2970w. Now the middle section. 990 times 3 times 600 again is 1,782,000. 990 times 3 times positive w is positive 2970w. When working on the right side, we're going to multiply the 10 to the 600 plus w times 600 minus w. Do you recognize that that piece is a difference of squares? When you multiply them together, you get 360,000 minus w squared. Let's multiply the 10 to that. 3,600,000 minus 10w squared. Let's do some combining on the left side. The w terms cancel away. and the two constant numbers can be added together. That makes 3,564,000. Next up, let's add the 10w squared to move it to the left side and subtract the 3,564,000 to move it to the right side of the equation. We would get 10w squared equals 36,000. Now divide by 10. W squared equals 3,600. Then take the square root. And the answer for W is 60. The variable W is representing the wind speed, and so our answer is 60 miles per hour. We just want to make sure that 60 is not a restricted value. When we look at our equation that had the variables in the denominator, we notice that the number that the W cannot be is negative 600 here or positive 600 here. So the answer 60 is just fine. The speed of the wind is 60 miles per hour. Let's summarize the lesson. We discussed a couple example word problems that created equations that had variables in the denominator. Both of our examples used math formulas, one for work and the other involving distance, speed, and time. But the only way to get experience with these kind of problems is just to keep trying and use solution guides if they're available. You do enough of them, at some point, you'll be able to get the answers without having to look at any hints.